Second question of this paper is from probability. This is a statement of the question. A sports event is taking place for 4 days. A sports event is taking place for 4 days, beginning on Sunday. The probability that it will rain on Sunday is 0.4. On any subsequent day, the probability that it will rain is 0.7. If it rains on the previous day, and 0.2 if it did not rain on the previous day. Part A of this question, find the probability that it does not rain on any day of the 4 days of the event. So this question is of probability. First we have to draw a possibility diagram. So we may have all the possible outcomes successfully. So we will draw a possibility diagram as a tree diagram. Tree diagram is a very specific possibility diagram. So first we draw the tree diagram to find all the possible outcomes. Read the statement of the question carefully. The probability 4 days sports event is taking place 4 days beginning on Sunday. The probability that it will rain on Sunday is 0.4. On any subsequent day, the probability that it will rain is 0.7 if it rained on the previous day, and 0.2 if it did not rain on the previous day. Find the probability that it does not rain on any day on any of the 4 days of the event. So we are drawing a tree diagram. On Sunday, the probability of rain, we represent rain for with this letter R. R dash shows not rain. It is given that on Sunday probability of rain is 0.4. We write here 0.4. 1 minus 0.4, that is 0.6. We write here 0.6. Now this is for Sunday. This diagram is for Sunday. Now it is given that if it is raining for next day, we draw again two branches against each branch. R, R dash, here R, R dash. Now it is given that if it is raining, then the probability for the next day for raining probability is 0.7. It is given. So we write here 0.7. Then R dash must be 0.3. Now it is also given that and 0.2 if it did not rain on the previous day. This is the previous day. Did not rain, then the for next day the probability of raining is 0.2. So we will write here 0.2. This will be R dash is 0.8. Now we will write here the possible outcomes are R, R, R dash, R dash, R dash, R dash. These are the possible outcomes. So we are writing here probabilities are r dash, sorry, r dash, r dash r dash, r dash. But we have to find, part A is find the probability that it does not rain on any of the 4 days events. Keep it in your mind that we have construct this probability tree diagram for 2 days. This is for Sunday, this is for Monday, because 4 days event is taking place 4 days beginning on Sunday. This diagram is for Sunday and this is for next day, I mean Monday. We have to find the probability that it does not rain on any 4 days of the event. Not rain for 4 days. So actually we have to find probability of R dash shows not raining. First day, second day, not raining. Third day, not raining. Fourth day, not raining. Now we will write here the probabilities. First day not raining, probability is 0.6. We write here 0.6. Next day 0.8, because uh, next day is this 0.6 for first day, for second day r dash, this is 0.8, so we write here 0.8. For third day, this is r dash. For third day we will make here again the diagram. For third day r dash, this is 0.2, this is 0.8. So R dash 0.6, R dash 0.8, and R dash is 0.8. For fourth day, again 0.2, 0.8. So we will multiply all the R dash. First R dash is 0.6, second R dash 0.8, third R dash 0.8, and fourth is also 0.8. So we are writing here 0.6 into 0.8 into 0.8 into 0.8. So we can simplify 0.6 into 0.8 cube. So after simplifying, we get the answer is 192 over 625. 192 over 625. This is the answer. Next part B of this question is find the probability that the first day on which it rains during the event is Tuesday. Find the probability that the first day on which it rains during the event is Tuesday. Event is taking place for 4 days beginning on Sunday. So we are writing here Sunday, then Monday, then Tuesday. We have to find the probability that the first day on which it rains during the event is Tuesday. Tuesday raining, Monday not raining, Sunday not raining. Not raining for Sunday. From here we can take help from this tree diagram and from this statement of the question to answer the parts successfully. Read the statement of the question carefully and observe this tree diagram to answer these questions. Sunday not raining, Monday not raining, Tuesday raining. Sunday not raining probability is 0.6. Monday not raining probability is 0.8. Tuesday raining the probability is 0.2. So we will multiply these probabilities. We get 0.6 into 0.8 into 0.2. After multiplying these values, we get the answer is 12 over 125. The next part of this question is part C of this question is find the probability that it rains on exactly one of the 4 days of the event. Find the probability that it rains on exactly one of the 4 days of the event. So there are different options for this. In this part, we represent R for raining and D for not raining. I mean D for dry. R for raining, D for dry. Find the probability that it rains on exactly one of the 4 days of the event. There are different options for this. First option is probability rain, dry, then dry, then dry, plus probability of first day dry, second day second day raining, third day dry, fourth day also dry. Third option is dry, dry raining and dry. Next option is probability of dry, dry, dry or raining. Now we will find these probabilities. There are four options. Now we will write here the probabilities against each of these. First we write here probability of R D D D. This will be first day raining. You will take help from R D D D R D D D. You will take help from here, but in this, be careful in this tree diagram. We represented dry by R dash. R dash means dry, not raining means dry. Raining 0.4, not raining dry 0.3. Then next uh, dry again 0.3. We can make here the tree diagram for this. Here the diagram will be 0.2 into 0.8. This is R, this is R dash. We are taking this R dash, that is 0.8. So 0.4 into 0.3 into 0.8. Next is also 0.8. You have to follow the instructions. You have to follow this statement of the question and this tree diagram. After simplifying it, we get 48 over 125. Next option is DRDD. DRDD. First is dry, from here 0.6. Next is 0.2. Next we can extend this. So 0.6 into 0.2 into 0.3 into 0.8. 0.6, 0.2, next is 0.3, next will be 0.8. From the tree diagram, you can take help from extending these diagrams following the statement of the question. Now after simplifying, this will become, sorry, this is not 125, this is, but this is 625, 48 over 625. This is answer of the first option. For second option, multiplying these, we get this 18 over 625. The next option is DDRD. Probability of DDRD, dry, dry, rain, dry. Dry, dry, rain, dry. 0.6 into 0.8 into 0.2 into next extend. We can extend this tree diagram. So next is 0.3. So we write here 0.6 into 0.8 into 0.2 into 0.3. After simplifying, we get it 18 over 625. The last option of this question is DDDR. Dry, 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 and raining. Dry, 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 and raining is 0.2. So we will write here 0.6 into 0.8 into 0.8 into 0.2. After simplifying, we get 48 over 625. Now we will add all these options. We will add up these answers of all the options, because there is a word or. Or mean addition in the statistics. So finally we get the probabilities Probability after adding all these options, we get finally the probability is answer of first is 48 over 625, second 18 over 625 plus 18 over 625 plus 48 over 625. After calculating all these options, we get finally the answer is 0.211. This is the final answer correct to three significant figures.